Gas boiler fault finding. My name's Alan Hart, and in today's video we've got his friendly ex-Ideal engineer back, and he's going to go through some fault finding on a boiler on an Ideal Logic. So hopefully this will give you a little bit of an insight into fault finding. Also in future videos, hopefully we're going to meet up and a better video together, and hopefully get some really good quality videos. So if you've got any videos that you would like us to do on fault finding, then please put some comments below and let us know. As always, in these videos are just for entertainment purposes only. Please do not look inside a boiler. Please do not mess about with multimeters unless you've been on the relevant training courses. Without further ado, let's go over to the Ideal, ex-Ideal engineer.
Good morning. It's me, I'm back again. I've been away a while, done some stuff, been some places, but I thought I'd make another video. I've not done one in a long time, and thought this one might be useful for people who are new to the industry. A lot of people probably know this, but I think it's useful to know for boiler repairs. And I'm going to talk about electrical testing of the boiler. I'm going to explain a few things, try and show you a few things, show you what I do. I do it on every job. And if you are a diagnostic engineer or repair boilers, this is really handy to know. Because a lot of people, when they repair boilers, they go for parts. Let's say you've got a fault with a pump and you're not getting power to the pump. People immediately assume it's the circuit board without even testing the harness. I've seen it so many times before. So I just want to show you how to do some electrical checks. Mainly they're gonna be dead tests. We're not going to be doing much live testing today. We're going to be doing like resistance testing and continuity testing. So thought I'd show you this here. This is the Ohm's law triangle. I'm not an electrician, by the way. I don't claim to be an electrician. I've done some electrical courses. I'm qualified as an electrician, but I've never really practiced it. I've never done any proper testing with megas or rewired houses. I only did it just because I wanted to understand the principles and apply it in my job. So please don't slate me, any electricians. I'm not trying to say I'm an electrician, but I just wanted, it's handy to know this if you're working on boilers and electronics. So this is the Ohm's law triangle, and basically the principle is with the you can work out either the voltage, which is V, I, the current, which is your amps, and R, resistance, is your resistance. So by multiplying or dividing or subtracting any of these two, you can find the other missing principle, if you will. So for instance, to find the amps pulling on a component, what have you, if you know the voltage and the resistance, you can divide the voltage by the resistance and it'll give you your amps. So you divide the voltage by R, gives you I. To find volts, you would times current by resistance. So you times these two together and you'd find voltage. And to find resistance, you would divide voltage by your I, which is your amps. And for an example, and I'll show you this in a bit later. So we've got an Ideal Logic 24 volt gas valve. So we know it's 24 volts, and we know that the amperage pulling through it is 0.2 I, which is 0.2 amps. So if I divide that 24 by 0.2, it gives me 120 ohms. So that gas valve in that boiler should be reading 120 ohms. And if it isn't, there could be a problem with the coil. So 120-ish, I mean, it could be a little bit over, like 10% over or under. If it's 125, whatever, you know, you'd be all right with that. So this is just a little bit of an example. I'm going to show you how to do some dead testing. Not just on the components, on the harnesses as well, because you want to be checking like the insulation quality of the harnesses. It's useful for checking them, especially over time when your product's been used and it's had heat from the boiler or possibly water damage on the harnesses, and it can have an effect on the operation of the cables. So like I said, people normally go for the parts, but it's not always the part. In my experience, I've had a lot of problems with harnesses, and so, you know, the test that I'm going to show you, they can detect like the impending insulation failure before it occurs, or it can detect faults that could put your life in danger. It could be causing a safety issue, or it could cause a fault on the appliance. So we're going to go to the boiler now, and I'm going to show you how I test the boiler before I touch it, and then I'll show you some dead tests on components, which is handy to know before you even put any live power to it. Obviously, dead testing is a lot safer as well, so you're not actually working with live voltage, which is, you know, always, you know, a better way to work if you can. So yeah, we'll go to the boiler now and we'll show you some tests. So here we are at the boiler. We've got our testing equipment set up, dust sheet down, and before we touch the boiler, we're going to make sure it's safe to touch. We've got a logic here. There could be a fault on the boiler, there could be a wiring issue that's causing the case to become live, and we don't want to just be touching it, taking the case off. So before we do any tests on the boiler, we'll use our non-contact voltage detector. These are not 100% effective. They are something handy to have, but I wouldn't use them for electrical testing. They're not really that reliable. You can get static that can cause it to go off, so just be aware of that. It's good for a quick reference, but nothing more than that. So what you'd do, you'd test it at a no source. I'm going to use the spur. You'd use a socket or something in the kitchen to make sure it's working properly, but for test purposes I'm going to use the spur. Then you'd wave it over the boiler casing. This is plastic. I'm going to use the side of the metallic casing. Most boiler casings are metal, so you can just wave it on the front, but on this instance I'm just going to use the side. Seems okay. Then you extraneous pipe work underneath. That seems alright. Back at the spur. Knock the power off. Now the next test we're going to do is we're going to test the earth from the spur to the boiler to make sure we've got a good earth as well. It's important to check the earth because obviously not just for safety purposes, it's also you know, the boiler needs a good earth for ignition or what have you. So I'll just set up the test and then we'll do that next one. Okay, so I've taken the cover off the boiler. The power's off and I need to make sure it's safe to work on, and I'm going to do what I call a dead live dead test. So I'm going to test the incoming live, neutral and earth while the power's off, test it while the power's on, and then test it while it's off again. And to do that I need an approved electrical tester. I've got one here, and I'm going to test to make sure that it works, it functions properly before I do any work on the boiler. So we've got a proving unit, and I'll push these two probes down, and then we've got the light indicators to say, there we go, to say that this proving unit seems to be functioning properly, and so does the tester. So we're going to expose the live, neutral and earth, and our first test is going to be between live and earth. So we'll get on the live there. And then earth, 0 volts. We'll go live to neutral. Zero volts. Then we'll go neutral to earth. So it's very difficult with one hand. Neutral to earth. 0 volts. And then any incoming switch lights, room stats, pump lights, anything else coming into the boiler, we also want to go across those to make sure they're not connected to a different power supply. So go across any other incoming cables. This has got a link in, but I'm just showing you that that is also 0 volts. Now what we'll do, we'll turn the power back on. And then we go live to earth again. Go to neutral. Sorry. Do that again. Live to earth 240. Neutral 240, neutral to earth, 0 volts or less than 15 volts. And again, go across any exterior power supply. See there, we've got a 240 volt room stat linked. So we've also done polarity there. We've not just done, you know, correct voltage coming in. We've also done polarity because we've got 240 between light to earth, 240 between light and neutral, and 0 volt between neutral to earth. So that's our polarity test done also. We'll knock off the power again. And we'll do it one more time. So we'll go light to earth, 0 volts. Go to neutral, 0 volts. Neutral to earth, 0 volts, and 0 volts on my switch lights. Again, go back to the proving unit one more time. There we go. And that's the first part of the test done. Now we're going to use our multimeter for the short circuit, resistance to earth and earth continuity. So we're going to set our multimeter to ohms. Again, touch our probes together. So we've got 0.9 ohms. So we'll subtract that from the tests that we carry out on this boiler. So we'll do resistance to earth first. So we'll go to live to earth and then neutral to earth. So what we're doing now, we're just making sure that we're not, you know, our cables are in good order. The installation is good order, and we're not inadvertently touching an earth. So what we don't want to see, we want to see greater, we want to see mega ohms or OL really. That's the desired reading we want. So we'll go live to earth. Oh well, mega ohms. So that means we haven't got a circuit, nothing's touching. Then we'll go neutral to earth again. Oh well, mega ohms, that's good. And then we'll go short circuit, which is live to neutral. We want greater than 15 ohms on this one. We've got 292 kilo ohms. So that's also fine. So we've not got a short circuit. Anything less than say 15 ohms or less, 10 ohms or less would be a short circuit. So we want mega ohms ideally, or OL, but 290 kilo ohms is far enough out that we know we've not got a short circuit. So that's short circuit and resistance to earth. So now we want to do earth continuity. So we want to test 1 point. This is going to be difficult, this, because I need to go to, I'm not going to do all 5 points. I'll just show you the 1 point when I can. So we put our probe on the earth, and our other probe, we want to go 5 points on the boiler. Try and jam it in if I can. So I'll go 1 point there, it'll hold on, and I'll touch the gas valve. .5, but we had 1 ohm with our lead, so we have to subtract the 1 ohm from our lead, so it's 1.3, which is good. I'll carry on while it's working. Pump. Again, that's a good earth connection. We'll go fan. Good connection. And I'll go detection probe. Again, good connection. So this is taking probably 5 to 10 minutes for me to show you how to do it, but if you're doing it by yourself, it takes literally 2 minutes. So we've done a safety touch, incoming earth to the boiler, dead live dead, short circuit, polarity, resistance to earth, and earth continuity. They're the main electrical checks. And now I'll expose the circuit board and we'll do some dead testing on components, and I'll show you the reading from the gas valve where we worked out how many ohms the resistance should be through it. I'll set that up now. Right, so we've determined that the incoming power cables are in good order, the correct way around with the polarity. You know, they're in good order. There's no short circuits. There's no you know, damage to the cables, and we know that any faults on this boiler would have nothing to do with the incoming supply. So we've ruled that out, and we've ruled that it's safe to work on. So now we're going to do some dead tests on the boiler. So the power's off. We can test for resistance, and we can test continuity through different components. So components like switches, like water pressure switch, air pressure switch, overheat stat, power switches on the boiler, they're all just continuity, so we just want less than 1 ohm through those. Anything that has like moving windings, pumps, fans, gas valves, thermistors, they're going to have a readable resistance that we're going to need to know what it is. Like I said, we worked out what the resistance on the gas valve is, and to test the thermistors you would need the thermistor chart. I think I've done a video about that in the past, so I won't go over that again, but I'll just show you how you would test the thermistor. So I've identified the harness, the thermistor harness, which is the black and pink, black and red on this harness, and as you can see, I'm on the black and pink there. I think the black and pink is the flow thermistor. And we're set at ohms, so all our tests are going to be on ohms because we're testing resistance or continuity. And we've got a measurement of 12.1 kilo ohms. So that's the flow thermistor we're measuring. Like I said, you need the thermistor chart, but I haven't got it with me. I'm just showing you how to do it, but I would say that that's okay. Just because the boiler's working, and it seems about right for, you know, what I should be getting. So now I'm going to go across these cables here. This is the gas valve, this is the stepper motor, this is the flow turbine and the low water pressure switch. So what I'm going to do, I'm going to try and get on the low water pressure switch with one hand. This is going to be very difficult to do. Just give me a moment. Come on. Come on. There you go. I'm on it. I'm testing the low water pressure switch now on the black and orange, and I'm getting 1.1 ohms. So that tells me that switch is in the closed position, which means it's working. So it's letting an ohm through it, which is a good circuit. If that switch was open and the pressure had dropped, you'd be getting mega ohms on that switch. So I know that switch is okay and working, and we should have enough pressure in the boiler. So that's the thermistors and the low water pressure switch done. Next one, so that's the low water pressure switch. This is the stepper motor, and this is the gas valve. I'm not gonna do the stepper motor one because I've done that on another video, and it's going to be difficult to do testing the cores individually. I really need two hands for that. I should be able to show you this gas valve one. So like I said, it's a 24 volt gas valve. We know we've got 0.2 amps running through it. So if I go across this one here, this one here, 112 ohms. I said it was about 120. 112 will do me fine. So we can test, you know, components. Dead testing the boiler is obviously safer. Switches will be less than an ohm. Thermistors, windings in gas valves, pumps, fans, you're going to need the readable resistance. You're going to need to know what it is. You can work it out by that Ohm's law calculator if you have the other relevant information, the voltage to the component, and you know the current that it's pulling in amps. You can work out roughly what it needs to be. With thermistors, they are a thermostat resistor, so you know, obviously with the temperature change, the resistance changes through the component, so therefore the current flowing through it changes, and which will change the amount of voltage that can be pulled through it too. So the low voltage that's flowing through the thermistor will change up and down depending on the temperature and resistance, and therefore the circuit board will see the voltage change, and with the algorithm on the board it will know what temperature that thermistor is at by what voltage it's getting back. Very low voltage it's getting back because the resistance through it is squeezing down the amps that can pass through it, or increasing the current that can pass through it, and therefore the voltage will go up or down, and the circuit board will calculate by what voltage is passing through it what temperature the boiler is running at. So that's just an electrical test that I do all the time. I don't skip this test. This tells me a lot, and then I can go looking for, you know, we can go looking for faults once, depending on what these tests say. And like I said, when you're doing it at the board, you're not just testing the gas valve. I'm testing the state of the harness too. So you know, if you've got a fault with the harness, this test here, you know, will show it up. So it's good to know, it's good to do, and if you're serious about repairing boilers, I would incorporate these tests into your working practices. Okay, that's going to be me for now. I hope this helps. I'm hopefully going to be doing some more videos with Alan, hopefully, on different boilers. I've not just worked for Ideal, I've worked for another manufacturer as well, so it'd be nice to maybe show some of the component faults and what have you on other boilers too. So if anybody wants to see it, that is. Yeah, well, we'll see what happens. Thank you for watching. Bye-bye.
Thank you very much for that, Mr. Ideal. If you want some more, if you want to see some more videos, then please put a comment below. Let us know what type of videos you would like. And as I've said previously at the start of this video, these videos, they don't take away the need for going on training courses. So in my opinion, go on as many of the manufacturers' training courses as you can. A lot of times, them training courses are actually free of charge because they use, or most manufacturers use marketing budgets to, obviously they want to sell you their boilers. So they'll use their marketing budgets to fund the training. So they're worth going on. Go on as many of the different manufacturers as you possibly can. And then also go on any local training centres if they've got any fault finding courses, if they've got any all to do with boilers really. And then the more of that stuff you can do, the better you will be, and the more you will learn. Different trainers and different people have different opinions and give you different processes, if you like. So if you go on as many as possible, then you'll learn the way that suits you and helps you the best. So yeah, thanks very much. Thanks for watching. Thank you to Mr. Ideal or Mr. X Ideal, and see you on the next video.